This is an example of an Excel spreadsheet to calculate a simple redox titration. We'll begin with the two redox reactions. In this case, iron 3 plus 1 electron going to iron 2. It has a standard reduction potential of 0.77 volts. Second reaction is permanganate plus 8 protons plus 5 electrons going to manganese 2 and water, and it has a reduction potential of 1.51. Since the manganese reduction potential is more positive than the iron potential, the spontaneous reaction is for the permanganate to be reduced and the iron 2 to be oxidized. And I've indicated those species in red. So the analytical system needs to react iron 2 with permanganate. We can do this in one of two ways. We can put the iron 2 in the beaker and titrate it with permanganate, and that's the example that I'm showing here. And in that case, the reduction starts low and moves toward more positive potentials. And alternatively, we could have put the permanganate into the beaker and titrated with iron, in which case the titration would look in the opposite sense. This simple titration system allows you to do the titration either way. The only sort of trick is that this number of electrons, n, would be negative. Now, clearly there aren't negative numbers of electrons. It's just simply carries into the Nernst equation and changes the sign. It's negative if E0 analyte is greater than E0 titrant in both of these cases. So if you were going to do the titration in the opposite sense, you would put in the standard potential for permanganate here, the standard potential for iron here, and the 1 and the 5 would be listed as the negative values. All right, you can play around with that after I finish reviewing the rest of the titration. So my analyte in this case is iron, so it is in the beaker. I need to give it the standard potential, the number of electrons transferred, the initial volume, and the initial concentration. My titrant is permanganate, and I again know its standard potential, number of electrons involved in the half reaction, the concentration, and equivalence volume is calculated, and it's calculated using the electron stoichiometry. So I just have that as a hardwired value. All right, E-reference is the reference electrode. So you're going to need some sort of reference electrode, and I've used the silver-silver chloride electrode. The step volume simply allows me to determine what the volume of each step of the titration is going to be. And then I've used a very standard partitioned approach toward calculating the titration curve. I start with volume, I fill it down, and I partition it into three areas. Volume less than VE. So if volume is less than VE, then I'm going to use the Nernst equation for the iron, because iron 2 is being oxidized to iron 3, and both are known. So $4, there's the 0.059 divided by n. There's the 1, that's what comes in. Log of B18, which is the volume added, C22, which is V equivalence, minus B18. So this is the volume of titrant added divided by the effective volume remaining in the titration to equivalence. At the equivalence point, we have the weighted reduction potentials. Remember that the weighting is N times E0 for the iron. In this case, 5 times the permanganate, C9 times C10, divided by the total number of electrons transferred. That would be 6. And so this turns out to be 1.38. So that's here. So for equivalence, we're coming along like so. Halfway to equivalence, the potential is equal to 0.77 volts minus E ref. At equivalence, it's going to be the average, the weighted average of the two reduction potentials minus E reference. And then after equivalence, I'll come down here, we have the similar format. Okay, now it's C9, 0.059 divided by 5, and in this case it's volume past equivalence minus the equivalence volume divided by the equivalence volume. So nothing new in this implementation, and that's going to give us the potentials up here. So in our final column, we use a lookup table or a Boolean statement. If B18 is less than C12, then use the first column. If else, use the first column. Else, if B18 equals C12, then you're at equivalence. Then D18, use the second column. Else, use the third column minus C14, which is the standard reduction potential. And here we go. We get a nice titration curve, redox titration curve. In this case, the titration of iron 2 with permanganate. And again, I'll leave it up to you guys to figure out if you like my negative N approach, or whether you simply make two titration spreadsheets, one with the analyte being the reduced iron, or the second one would be the titrant being the reduced iron.